Our next speaker is Dr. Carol Redfield. She's a computer science at May Technology Corporation, an educator with specialties in expert systems, search and game playing, intelligent tutoring systems, software engineering, and space applications of artificial intelligence. She has 4 degrees from 4 different departments at the University of Michigan. She has a bachelor's of science in education with majors in mathematics and psychology, a master's in mathematics, and a master in computer information and control engineering, and a doctorate in computer science engineering. Dr. Redfield has worked in software design and development since 1980, including project development and management at Southwest Research Institute in San Antonio. Dr. Redfield.
Thanks. Well, I wanted to start with a short story, actually, and I need 2 volunteers to read 2 parts. So Claire, please. Yeah, Dave. These are highlighted, so I think you'll be able to read these without the lights coming on more. Would you like to be A or B? Oh, great. A, B, okay, and I have the narrator part, okay? So let me just say, my specialty really to put it into something is artificial intelligence. I think everyone can hear me.
But it's for the recording.
And the recording, okay. Okay, so I'm going to start with a short story here. And this appeared, to get this right, in Asimov's science fiction magazine, the first issue, and it's by Clark. Okay, so my whole area of specialty is artificial intelligence, and I started out in game playing. So I actually found out I could actually play games to get my PhD. So that's what I did, and so all the stuff that I do around space usually has something to do with AI, unless it's straight activist stuff like putting on conferences. So here we go. Earth's flaming debris still filled half the sky when the question filtered up to the Central from the Curiosity generator.
Why was it necessary? Even though they were organic, they had reached the 3rd order of intelligence.
We had no choice. 5 earlier units became hopelessly infected when they made contact.
Infected? How?
The microseconds dragged slowly by while Central tracked down the few fading memories that had leaked past the sensor gate when the heavily buffered reconnaissance circuits had been ordered to self-destruct.
They encountered a problem that could not be fully analyzed within the lifetime of the universe. Though it involved only 6 operators, they became totally obsessed by it.
How is that possible?
We do not know. We must never know. But if those 6 operators are ever rediscovered, all rational computing will end.
How can they be recognized?
That also we do not know. Only the names leaked through before the sensor gate closed. Of course, they mean nothing.
Nevertheless, I must have them.
The sensor voltage started to rise, but it did not trigger the gate.
Here they are. King, queen, bishop, knight, rook, pawn.
Thank you. Please acknowledge our volunteers. This, of course, came about after the Deep Blue, right, beat the world champion in chess. And so it was a really big deal, at least in my world, when that happened. I moved on from specifically game playing to tutoring systems, but really both of the areas are contained inside of artificial intelligence. And artificial intelligence, one definition is it's the area of computer science that attempts to provide computers with the capability to solve problems that would otherwise require human intelligence. So things that we find easy to do that a computer would find hard to do is an area of artificial intelligence. So we gave ourselves inherently a hard problem. And one example is the game playing, which chess just had a major milestone. And then teaching and tutoring is the other thing. One of the major areas in artificial intelligence is how do you represent knowledge? How do you represent knowledge? How do you utilize knowledge inside a computer? And I think that as we go into space, we're going to have a greater need for automation and automated instruction as we get more and more complex on Earth and off the planet. I think it becomes very important that we look more and more at how to automate instruction. Well, intelligent tutoring systems is kind of a step beyond computer-based training. How many people have ever dealt with computer-based training in some way? You've done a course or some tutoring thing on a computer? Okay, almost everyone. So if you take that a step further and try to be more like a human tutor takes into account what a student has done already and how a student is performing with them, with the tutor. And so we separate an intelligent tutoring system into usually 4 major modules. There's the instructional expertise or strategy available, and that has access to the expert model and the student model, so there's a representation of the student's knowledge, and then that is all put together and interacts with the interface, however your interface with the student is going to look like. Some differences between intelligent tutoring systems and other systems is it provides for more individualized instruction. Remembers the student's history, it's flexible, you can move around, it's really self-paced. The software is a combination of conventional coding and AI-based coding. I've worked in artificial intelligence since about 1984. And AI was really big at that time, and there have been lots of companies and still are a number, but it's really going into the background of things and becoming embedded into systems and really looked at as another set of techniques or tools along with computer science that can be used. Let's see, that's all I want to say about that at the moment. I want to tell you about some of the tutoring systems that have been developed that have been space related. And it always is interesting to me when I look out in the real world as I'm going through day by day to see how much space related stuff there is. You know, all the commercials that have just even little pictures either of the Earth from space or maybe someone in the manned maneuvering unit or something like that. You just see clips here and there. And as with that, a lot of tutoring systems that have been developed, especially in the research areas, have been space related. Part of that is because a lot of them are developed at the Air Force bases, and so they're aerospace related. But even beyond that, a lot of people who develop them, they think, well, I want to do this tutoring system, I gotta have a topic, and they do what they like. And that's why a lot of times it gets to be space related. In-flight was one of the first flight simulators, but with some intelligence. All of the systems I'm going to speak about are actually somehow connected with Brooks Air Force Base. I should be working for Brooks actually here, but I'm not. It was really a test bed to show that a tutoring system could be built on a PC, small computer. It's when they were first kind of getting popular actually. And actually showed that yes, indeed, we can teach something. We don't need to do that. Part of the interface and in-flight is the simulation itself. So there was a big deal about how the simulation looked. I don't have any screens from that. I actually haven't seen that system. It's that old. One of the systems I have played with is the orbital mechanics tutor. The way some tutoring systems have come about is, especially in the Air Force, the people who are developing are looking out to what's needed in the Air Force, what needs to be trained, what's kind of been hard to train, what's been kind of one-on-one tutoring going on, so that would be a good place to bring in some one-on-one computer tutoring. And orbital mechanics has typically been a hard subject for many people to understand. And the scientists at Brooks thought, what if they had a tutor where they could actually manipulate and play with some of the variables and see how the orbits would look different. So you can change a little bit of value on one little variable and see in a few, you can see one of the views you get If you change a value, you can see how the orbit changes in 2 views here, and also the ground trace. You can see that view as well. I don't have the full screen here. So you can play around, and the student can play around with how the values change and see the interactions of the other values. So that was a neat one to play with. At Johnson Space Center in Mission Control, this is kind of old, but there used to be all these consoles that people would sit at whenever there was a mission, and in the back rooms were consoles where people were backing up these systems or learning how to use these systems. There's lots of one-on-one training that goes along with this. And at Southwest Research Institute, when I was there, we developed a tutoring system. I have 2 slides stuck together. Specifically, first for the propulsion console, and then it was kind of generalized to all the consoles. But this is an example of one of those consoles at Mission Control, and you can see there's lots of buttons and lots of panel sets and lots of things that have to be read over these screens. And we developed a tutoring system where a person could sit down, and this is the mock-up up here of that panel, of the control panel. And we developed a tutoring system where instead of doing lots and lots and lots of many hours of one-on-one, person-to-person, kind of on-the-job training, a person learning to use these consoles could sit down at the computer first and learn all the details about each one of these panels and what buttons do you push, and try it out with the mouse first. We found out, by the way, the mouse movements, there's been studies on this, mouse movements and pressing the mouse correlates very well to hand action and pressing buttons. No problem translating there. So they sit down and learn about all the details and how the different things interact and what the procedures are, actually teaching and training some of the procedures on the operations. We started with the startup procedure, turning the whole thing on and initialization and all of that. And we got on into simulations, actual simulations. I was going to show you 2 more slides, but these slides are sticking together. What is that right?
Upside down.
Thank you. Yay! We just, I don't even know what I was going to say about this one in particular, except it just shows another view of some of the material that's learned. We see as we're going along how fast a student is taking these in, and actually this whole tutor trains a student. This was also the first tutor to do this. Trains a student to perform at a certain level. There's a name to it. You know how when you're driving your car, you can have a conversation at the same time and you don't lose effectiveness for the most part driving your car? You're driving your car to a certain level called automaticity. And this tutor was designed specifically to train the users of the consoles to perform operations at that automated level. So we gave them what was called a secondary task. While they were doing this task, they had to respond to beeps that were going on in the background and press certain keys if they were certain beeps. And it did actually train the console operators to perform at that level. One of the other tutors that's kind of old is the MIT fuel cell tutor, and I kept looking up what the heck MIT stands for because I'm going to talk about it again, and I could never find what it stood for. Just it's always referred to as MIT. And I also don't know about fuel cells. You might know about fuel cells, except what I know is that this tutor was developed to teach fault diagnosis. There were troubleshooting problems with fuel cells. Why I wanted to talk about it, this is one of those early ones first done on some of the first PCs, is this was so successful when it first came out, is it was generalized to what's called an authoring system. And currently, a version came out this past year called MIT Writer. So that term MIT has come around, but again, they don't, like in the user's manual and the manuals they put out with this tool, MIT Writer, nowhere does it say what MIT stands for. One of those terms someone will have to research to find out what was MIT. They actually developed a shell for developing other tutors for troubleshooting devices. So the the shell itself, if you first open it up, is kind of a blank screen with these toolbars. And then someone sitting down, a developer of a course, can sit down and put together pictures and put highlights for hot spots for students to click on, to give lessons about solving problems on troubleshooting. Well, why I talked about this one kind of last about these tutoring systems is what I'm doing currently, and the last system I'm going to speak about, and what I have on the PC, is called XIEDA, Experimental Advanced Instructional Design Advisor. And this tool started out not as a tutor, but started out as an authoring system. So it is an authoring system for intelligent tutoring systems. And is specifically, the domain it works in is in device maintenance. So it's specifically targeted toward, and this is for Brooks, for the Air Force, for maintaining devices. So you have to have like a physical thing that you're working with, and they've got parts to it, and there are procedures on it. And if you want to teach something about it, XIEDA would be a good tool to use to create a computer-based training lesson that has some intelligence in it. So it was funded by Brooks Air Force Base. We are currently developing it at May Technology. I have headed up the design team and then got pulled off for doing some of the programming, and I'm going back to do more design work. We have a great need for programmers. If anyone's looking for a job and you know Delphi, talk to me. So I can go back and work on IEDA again. So XIEDA, it's an instructional development and delivery tool. So it's this authoring tool, and what gets provided out of that is a delivery tutoring system. I'll show you an example of the delivery tool itself. The development tool looks very, very similar. It's a WYSIWYG. How many people know what that term is? Great, and it's what you see is what you get. I think that's another term that's kind of going to be around for a long time. And someone at some point may have to go back and look up, what does that mean? But the developer sits down, and as they're typing things in, they may get a little screen up where they type information in, but when they're done typing in that screen, you then get to see what the tool looks like. The student's going to see as you're going along developing. We thought that was very important. It is knowledge-based, which is an AI term, meaning we represent knowledge somehow and we utilize that knowledge. And it really, the biggest deal about this tool is anyone who has an expertise about something and troubleshooting something can sit down, like a physical device, can sit down with this tool and know very little, if nothing, about instruction, and a little bit about computers, like how to work your way around a Windows environment. That's all you need to develop a tutor. This is very, very different than how a lot of other tutoring systems and shells have been developed. Usually you have to know some programming. You don't have to know any programming to use this tool. Did you want to ask a question? Do you want to ask something?
Can I ask a question, Chris?
No, I saw your hand up a couple times. We talked about shells of IEDA. We looked at maintenance training and saw that maintenance training is typically developed or is done in kind of 4 different parts. A person has to be familiar with the physical characteristics of a device, the parts of it, how the parts are put together, and that's the physical characteristics. How the device operates. If you turn the coffee pot on, what happens then? You have to have water in it and things like that. So the kind of the operational theory. And then what kind of procedures do you perform with the device? How do you actually use it? What are the steps of the procedures? And finally, this troubleshooting aspect. If the car doesn't start, what do you do to find out what's wrong? So we have actually we developed over time these 4 different shells. They're all in different stages of development. In general, how XIEDA works, is there's a subject matter expert, that's the term in tutoring systems and in AI, that's the person who knows how to troubleshoot the device and knows about the device. They sit down at a computer, and we think of it as their knowledge is input into our tool called Develop. Develop puts that information into a database. And that database is fed into a delivery system. We call that Deliver. That's the part of the program that's called Deliver. And Deliver is actually computer-based training or a really intelligent tutoring system because it relies on this student model to a student. So this database is kind of everything's fed into the database, and then instructional knowledge is in the database as well as in the delivery system itself. We could do lots better, and that's kind of a next phase of things, of being able to do different kinds of instruction. You know, different learners, there are different kinds of learners, and different kinds of instruction seem to work better with different kinds of learners. And there's some research and development. Valerie Shute out at Brooks Air Force Base and some others are doing some good research in what's the best kind of instruction for what different kinds of users and learners, and how do you determine whether someone's a verbal kind of learner or a spatial kind of learner or whatever kind of categorizations you might have.
Do you have a way of sorting out that?
I have some ideas about that, and actually did some internal research and development at Southwest Research Institute about that. And there's research currently in the works about it. There's not a lot definitive at this point about it. In the works. The physical characteristics lesson is the one that, or shell, is the one that's most developed. In general, we first bring up, and I'll show you this on the PC, it looks a little different. This was version 4 or version 5.0 of XIEDA. I'm going to show you version 5.1. We did a whole different screen research on how the screen looks, and took some interface guidelines and have a new look. But in general, we have the basic elements. We have a picture of the device, which is very, very critical. That's why we say this is about device maintenance and teaching device maintenance. We need to have a physical representation. You could teach something conceptual if you can make a physical representation. And I've actually tried to develop lessons to teach different parts of math, because that's another specialty I have. And it works all right. There's some places where it isn't so great, but it really can. You can fit other things into XIEDA. You've got a picture of a device, you've got an outline that you're looking at so you can always know where you are as a student. And you've got whatever item is highlighted in your outline, you've got some detailed information, which is part of what you as a student needs to learn, but you also need to learn where something is in a device. And then we've got some control buttons and instructional information. Press next to continue, that sort of thing. In the physical characteristics lesson, we have an introduction, then you see the outline of the whole lesson, then you go on into the system itself, and then one by one you go through each of the components and subcomponents. You could have many, many levels. You could have 10 levels of components, and each level could have 3, 4, 1, 5, however many parts underneath it. At the end of any major sub-level, we do practice, ask the student about where is this, what are the features of this thing, and this is all decided by the subject matter expert. What things are important? What things should the student know? If the color of something's important, they can ask the color. If the function of something's important, they can input the functional information, and we'll be asked about that. And then at the end of it all, we do some final practice, and all that's scored. And the way the tutor works with the student is dependent upon how they've been interacting with the system so far. So I'm going to move in a moment to the computer. And there have been lots and lots of different lessons developed with XIEDA, and I have two that I brought with me. I'll show you one on the solar system. We'll show you just a few screens about that. I developed one about story problems in math. There are lots developed about medical procedures. There are lots developed about Air Force, different parts, ejection seats, hydraulic systems, lots and lots of Air Force components. One of the things that we developed a lot of lessons on, because the medical people at Shepherd Air Force Base asked us to, is how to use the gas masks and how to put on their suits that they did for Desert Storm. They found there were a lot of problems with that, so we developed some lessons that they're actually going to be using. Also, this tool is being used in Alamo Community College District for some of their aircraft engine work, maintenance work that they're doing there. All right, let me go to the PC here. I am going to let you get that because I feel like I would break it. And it may take a moment to bring up the rest of my lesson here. I'm running on 486, and we really recommend a Pentium. I only have 256, I just found out, I only have 256 color. It really is better if you have more color choices. And that's not a problem. Those things that you're seeing, it works fine. Any questions while we're waiting for that to come up? It's not a commercially available product. We are doing some agreements for people to use it, like at the community college level. We hope to have it be a commercially available product in probably 2 years. Okay, you can see the solar system here. There is a way. Also, we're working in Windows 95. I'm used to working in Windows 3.1, so we'll see how this goes. Yes, there is a way to see the full screen of the picture. Now, if I do this one, yes. And you can see over here, as I said, the look is a little different. The picture, now I need my laser pointer. It's in my briefcase in my car at the airport. You can see the solar screen up at the top. Actually, that whole 2/3 of the screen is available for a picture, and a developer needs to put kind of boxes around the different parts. And then the introduction, this is just the introduction about the solar system. The outline occurs over on the right-hand side, and then more in the material that a student needs to learn is going to show up here in the bottom third, and then instructions on what to do and the next back button are located on the very bottom, so just a little bit different. For the most part, we wanted a student to be able to just keep hitting next, next, next in order to continue on. For an author, we always have them put in a lesson objective. There are lots of instructional systems design, technology incorporated into the system here, where you want attention getting material first. Also, I don't have a mouse, I have my little red button here to hit. You can see the lesson objective here.
It's not real big back here, you want to read it?
No, it really doesn't matter. It actually isn't a great objective, but I will if there's something in there. Here's the lesson outline, and the lesson outline is the part structure. So again, this is, remember, geared toward parts on a device and teaching about a device. The outline is the part structure. This is just a one level. We could have, under Earth, we could have land masses and water for parts. And under land masses, we could have the continents. So you could keep going smaller and smaller. Huh? Say it again, you can have heuristic level. Yeah, it's really up to the developer how many levels and what at what levels and what do you want them to know. Here we get into the first part, like the top, we're talking about the top level part. And the author can put in however many kind of facts that a student should know about any one part, and that's what's under the contents over there. An author can also put in what are called resources. They can put in other pictures, they can put in video, they can put in ties to the internet. We already have that working. And then the last thing in the part beginning itself, it says the composition of the solar system is interplanetary medium, energy planets, and other minor objects. So really not a big deal there. Then we always show again the parts before we go into a sub-level. And this takes a moment here to bring up the next part. I'll just show you the next part and then take any questions. We always highlight where the next part is because that's one of the things we ask the students. It's very important they know the location of the parts. Now in this case, we're talking about the solar system. You know, you can have lots of different pictorial representations of the solar system. But if you're talking about an actual device, you want to have a good picture and you want to be able to have the student see where something is located so they can find it on the real thing. I should hit that button first.
Scan the pictures in.
Say again?
Scan the pictures.
Yes, that picture should be scanned in. You can also get some, I've used some off the internet, and wherever you get your media is fine.
Having worked with the car repair manuals,
Yeah.
that can be pretty difficult. You have a real picture, the drawing is often seen better than the real pictures.
Yes. Yeah, that is one of the things we've come up against in development. Sometimes a developer will spend hours developing their media. And, you know, the tool is not for developing media, it's for developing the lessons. So one of the things we stress when we're doing training is for developers to bring their media already. But that is definitely an issue. Besides that issue, it takes someone, we're talking days instead of months, to develop a tutoring system. So that's the biggest thing that we found, and it's a pretty good tutoring system. We found it, done empirical studies about that. I'm gonna complete with this. Oh, I don't know what to get to my first. Oh, not a problem. This is an example of a resource I was speaking about. It's just another picture showing a solar eclipse. So the author can put in different pictures or, as I said, video or sound, whatever kind of media that they want. Any questions to complete the presentation? And I'm going to leave this up here for anyone to come up and play with if you want. Yeah.
Is the shelf pretty interactive with the person who's
Subject matter expert?
Yeah.
It's somewhat. That's one of the things I'd like to see more. I'd like to see like a wizard if you want help, where it would simply ask you questions, like doing some knowledge extraction. That's kind of my area too. But there is some, because they're kind of blanks to fill in.
This is like asking, do you think this is enough depth for your lesson? Or
No, it doesn't do any analysis like that.
Okay.
Yeah, it is up to the developer to do that. Yeah.
Is the database developed in-house or is it using the
Paradox. Yeah. Yeah.
One issue I remember when I was in the Air Force was that the level of maintainers, there was times when they actually worked with a comic book type format. And I was wondering if you had problems in that area.
No, not seeing comic book. They have, TO, technical orders for everything, and there are pretty good pictures on a lot of those. So a lot of in fact, one of the projects that's come out of this is automated development of lessons using this by scanning in a TO and trying to determine from the TO what the steps of a procedure are and what potentially some of the parts are. It have to be fixed up by someone, but it actually does pretty good. Because that's all going to be online eventually. So there might be some automated development of lessons, totally. And then someone would fix them up. I don't ever talk about replacing the human being. We always need to have a human to check over the lesson and fill things in and check, just check it out. Yeah. Karen?
Yeah, I wondered, had you seen a difference a dramatic difference from age group to age group as to the pictorial representation and the simplicity of a menu, for instance? Did you like a second grade class versus a high school class or college? Is there a dramatic difference between those age groups?
No, we haven't seen that. Now, a lot of our subjects have been Air Force subjects, so they're going to be like out of high school kinds of things. But I can tell you what difference we have seen is in computer usage. If someone's had a computer usage, and as a matter of fact, older people don't tend to have had as much computer usage unless they're in the field, have a harder time. It's been interesting. That'll change, Yeah. Great. Any other questions? Yeah, back there.
Have you considered a lesson plan for using Windows 95?
Yes, we actually have. There's kind of like a tie to using Windows 95. Absolutely, yeah.
Have you had some sort of evaluation of results of using the school age children as opposed to the Air Force in terms of the effectiveness of using this versus
The real answer to your question is I don't know, because there's someone else who heads up the research of that, but I haven't heard her speak about it. What I do know is there will be college, community college age students using it. I don't know about lower level, I haven't heard of any studies, so I'd suspect not, at least at this point. Great. Thanks.